Okay, welcome to the discussion for section 3.3. There's a few questions on this one, primarily the first couple where we have this D, Q, and R kind of stuff. So let's take a look at those. We're going to start. Let's look at problem number 3. And we have P is given to us as x to the fourth minus x to the third plus 9x plus 2. And D is x squared plus 8. So what we're really looking for, we're taking the polynomial and dividing it by D, the polynomial P of x, D the divisor, right? So what we're really looking for is this x to the fourth minus x to the third plus 9x plus 2, all divided by x squared plus 8. Right? And this is going to equal something, right? It's going to equal, they have it as Q, the quotient. But it's not always, it doesn't always go evenly, right? So this quotient might have some, and it'll be some function of x, right? So it's going to be a new function, but it might have some remainder that I can't divide this by. So r of x, I'm going to back up and start using symbols here for a moment. I apologize, but it's this P, the polynomial when it gets divided by the divisor, if it went evenly, it would just be some nice quotient. If it doesn't go evenly, we would say that we have some remainder, and that remainder just stays over that divisor, right? So this division yields some polynomial function plus some junk that's left over that original divisor. But if I multiply everything in this equation by D, then I have, I'm going to multiply on the left here. The d's cancel out, and I can then say my polynomial is then just the divisor multiplied by the quotient. And then the d's cancel out here plus some remainder, right? And this is how they want you to put your answers, and this is, I think, where most of the confusion is coming from, because we're typing all of this crap into a system. I don't like the way these questions are written, so I think questions 1 through 6, I'm going to request the guy go back in and rewrite them, because they're not great. So if you're having trouble because of the way it's input, you're not alone. I don't like them either. But let's do it, because all I really need to do is perform this division and figure out what Q is and figure out what the remainder is, and then just rewrite it in this format, right? And that's what they're asking us to do. So I'm going to take these two things and divide them, right? Which is to say that I have that division. I can't do synthetic division because I have a second degree polynomial in my denominator, so I have to go out and do log. So I'm going to go x squared plus 8 into x to the fourth minus x to the third plus 9x plus 2. And long division here in polynomial world is just like long division in regular number world. Each of these can be considered just like a place value, kind of like these guys here. But I'm going to take this very first x to the fourth on the very first term on the inside, divided by the very first term here. So x to the fourth divided by x squared. That would give me x squared. And then I'll take this x squared and multiply it through everything on the left and subtract it from the bottom, right? So that is to say x squared times x squared is x to the fourth. X squared times 8 is 8x squared. And so since I don't have an x squared in my polynomial, I'm going to kind of scoot this stuff over. So I'm going to say that this would be like 0x squared, right? And so my 8x squared is going to go under my x squared. And again, I want to subtract this from the top, so I'm going to subtract. X to the fourth minus x to the fourth is 0. I want that first term to be gone. There's nothing here, so negative x to the third just drops down. Nothing, minus 8 is minus 8x squared, and then plus 9x, and then plus 2. And I'll just keep going through that kind of algorithmic process until I can't do it anymore. The first term is now negative x to the third, divided by x squared is negative x. So minus x, and I'll take that minus x multiplied by x squared is negative x to the third, which is good. These two should always kind of match up. Negative x times 8 is negative 8x. Oops. Sorry, that's my x squared column there. Put it under your x term here, so minus 8x. And again, I'm subtracting, but these guys are already negative, so make sure you change these signs to pluses so that you can then combine, because I'm subtracting negatives. So this first term again should always disappear on you, and it does. This next guy in this case drops down, so I have minus 8x squared. 9 and 8 gives me plus 17x, and then I have this plus 2, right? Looks like I'm getting towards the bottom of my screen here. But I'm going to keep going here. Negative 8x squared divided by x squared is just negative 8. Right. Multiply it up here gives me negative 8x squared. Negative 8 times 8 is negative 64. When I combine these, I've got 0 there, a 17x. Can you see that? Can't tell because there's some junk in my way. Looks like it, yeah. That gives me plus 66. Right. And I can't divide anymore. 17x divided by x squared isn't going to go evenly. I still have some junk in the remainder, in the denominator. So this is my remainder, right? So I can write this as x squared minus x minus 8 is my quotient. 17x plus 66 is my remainder, right? So let me write this up here. Q of x equals x squared minus x minus 8. R of x is what's down here, is 17x plus 66. Right. So if I then write this as my polynomial can be rewritten as they have d of x times q of x plus the remainder of x, right? D was my divisor. That was what was in the denominator, which was x squared plus 8. And I know there's a lot of parentheses going on here, but these parentheses are around d of x, so that's just a parentheses around the factor x squared plus 8. These parentheses are around the quotient, which is x squared minus x minus 8. And then I have this plus r of x, which should not be in parentheses, so it's plus 17x plus 66. Right? So again, I hear you, I feel you. Questions 1 through 6, where they ask for this d of x, q of x, r of x crap, it's not the greatest, but the process of that division is what you should focus on. All right, let's look at number 8. Number 8 was asked. Number 8 says, use synthetic division and the remainder theorem to evaluate P of C, where P of x equals negative 2x to the 7th minus x squared minus 2. And and we're asked to evaluate when C is 1. So really all it's asking me to do is plug in 1 in here. And the value of this is if I plug 1 in here and I get a 0, then x minus 1 is a factor, right? And so plugging 1 in here gives me negative 2 times 1 to the 7th minus 1 squared minus 2. That is to say, 1 to the 7th is still 1, times negative 2 is negative 2. 1 squared is still 1, and so it's minus 1, and then I have minus 2, and so I have minus 2, 3, 4, 5. It's minus 5, and therefore I would know that 1 is not a 0, right? And let's look at, finally, 13. 13 says, find the quotient and the remainder. So this is how I think questions 1 through 6 would much better be written. But we're asked to find x to the third plus 5x squared plus 7x plus 5 divided by x plus 5. We're asked to find the quotient and the remainder of this. We don't have to write it in any funky d, q plus r garbage. But if I'm doing this, I'm just going to take this and write it as x plus 5. Well, should have given myself more room. Just take the x plus 5 out to the left. The denominator goes out to the left. And then I have x to the third plus 5x squared plus 7x plus 5. And go through that process. X to the third divided by x is x squared. X squared times x is x to the third. X squared times 5 is 5x squared. Remember to change your signs here because you're subtracting, so minus and minus. X to the third goes away, 5x squared goes away, and I drop all the way down to 7x plus 5. So I take my first non-zero term and divide it. 7x divided by x is 7, so that's a plus 7. 7 times x is 7x. 7 times 5 is 35. Don't forget to change those signs, so minus, minus. 7x goes away, but I've got 5 and negative 35 is negative 30. So my quotient is x squared plus 7. While my remainder is just negative 30. And there we have it. All right. Hopefully that was helpful. I will see you guys for the next one.